Okay, going over section 1.1, linear equations in one variable. So this was intended to be a warm-up that we could do together. So I guess I'll mostly do it for you. This is sort of how your grades get calculated. Let's say it's right before finals week, and you want to know what score you need on the final to get a certain grade in the class. At this point, you would know all of your scores except for the final. Let's say you scored a 90 on the first exam, which is worth 25% of your grade, and 87 on the second exam, which is also worth another 25% of your grade, a 93 for your quiz average, worth 10% of the grade, and a 95% homework average, worth 10% of your grade. What score would you need on your final to get an A-, which is really a 90% for the course? So typically you would calculate this using everything we're about to do in this section, but I want us to do guess and check so that you can see why it's beneficial to actually have a methodology for solving linear equations. So the way that this would begin would be 25%. So again, you now know what the worth of each thing is. So 25% of your grade means that you would take 0.25 and multiply it by that score, which is a 90. Oops. Then you would take another 25% times your second exam score, which is an 87, plus you would take 10% times your quiz average, which is a 93, plus 10% times the homework average, which is a 95, and then the final is worth 30% of the grade, so 0.3 times the final would have to equal 90 points in order for you to have an A-. So let's actually do the calculations. 0.25 times 90, I'm trying to pull up my calculator, 0.25 times 90 is 22.5 points. (25% of 87 is 21.75 points. 10% of 93 is 9.3 points. 10% of 95 is 9.5 points. 0.3 times the final, we don't know the final, would equal 90 points. So adding these all together, you get 63.05 plus 0.3 times your final grade has to equal 90. So let's guess, make guesses for what F would be. So if the final were 100, that would contribute 30 points because 0.3 times F, 0.3, 30% of 100 would be 30 points. So that would be larger than 90. So that's not the lowest score you need to get to be able to get an A-. So what if the final were worth, let's say, 80 points? Let's go in the other direction. That's probably too low because let's actually calculate that one. 63.05 plus 30% of a score of 80, does that equal at least to 90? I don't know. 0.3 times 80 should be 24 points. So 24 plus 63.05 looks too low. It's only an 87.05. It's not an A-. So what score do you think might work? If 100 was too big and 80 was too low, maybe we need 90? – 30% of 90 would be 27 points. You add them together and you will get 63.05. Oops, I'm not doing well with my calculator. 63.05 plus 27 is 90.05. I think if you go any lower, you'll be below 90 and you won't have the A minus. So it looks like you would need to score a grade of 90 on the final in order to be able to have a 90 for the course. Now, of course, this is not the typical way one solves a linear equation. And I think you probably know this. If you had an equation like 4x plus 8x is equal to 17x minus 9 minus 1, you would have to combine your like terms on the left and combine your like terms on the right to simplify this. 4x plus 8x is 12x. On the right, you would have to combine the negative 9 and the 1 to make negative 10. Then subtract 17x on both sides. Oops, that's not like 17. That cancels, leaving a 0 there. But typically we don't write the 0. This says that negative 5x equals negative 10. Finishing that over here. Dividing both sides by negative 5. We get that x is positive 2. For this next example, I'm messing up. X is positive 2. For the next example, which I'll do in green, again, you have to do some complex simplification before you can begin to solve this. So you will want to distribute this 4 through to everything in there. So you'll have 5p plus 4 times 3 makes 12. 4 times negative 2p is negative 8p. On the right, you have 2 plus p minus 10. So combining the like terms on the left, that's the 5p and the negative 8p, you get negative 3p plus 12. On the right, you want to combine the 2 and the negative 10, which will give you p minus 8, because 2 minus 10 is negative 8. I just wrote 10 for no reason. Now you have to move all the p's to one side, all the constants to the other side. Typically, everyone prefers to move the variables to the left and the constants to the right. I don't have the most space in the world here, so I will rewrite this. And use some colors to help us. So I'm going to move p over by subtracting it on both sides. But just to make things easier, why not also move the 12 over to the other side by subtracting it? Cancel, negative 4p equals, these cancel, negative 20. So p will equal, divide both sides by negative 4, p will equal positive 5. Moving on to an example like number 3, this is not all that straightforward to solve. Of course, you can find a common denominator, but that really is not going to be very much fun to use to maintain the fractions throughout this. What you really want to do is multiply through by a whole number that will eliminate your fractions. Because this is an equation, you're allowed to do whatever you choose to do on both sides of the equation. So if we were to multiply by, say, 14, the 7 in the denominator would cancel, as would the 2 in the denominator. So let's multiply everything here by 12. So you'll have 12 times, not 12, 14. I don't know why I just said 12, I'm sorry. You'll have 14 times 2p over 7 minus 14 times p over 2 is equal to 14 times negative 3. What happens then? 7 goes into 7 once, 7 goes into 14 twice. That will give you 4p minus, same thing here, 1 and 7, that gives you 7p, is equal to negative 42. So again, let's pull that over here. 4p minus 7p equals negative 42. That gives you negative 3p is equal to negative 42. Divide both sides by negative 3. And you get the p is equal to positive 14. Let's do this last one. Again, look at the denominator. 2, 4, and 2. It might be nice if we could do something to help us get rid of this denominator. And again, we are allowed to multiply by a constant that 2 and 4 divide into evenly. There's more than one choice. You could choose 8, but why not choose the smallest number possible, like 4, because 2 divides into 4 and 4 divides into 4. So you'll do 4 times k plus 1 over 2 plus 4 times k plus 3 over 4 is equal to 4 times 1/2. This will cancel, giving you 2 over 1 times k plus 1, which is really just 2 times k plus 1, plus. Again, this is 4 over 1. These 4's will cancel, leaving 1's everywhere. So 1 times k plus 3 is what you have next. And on the right, 4 times 1/2. Again, 2 goes into 2 once, 2 goes into 4 twice. You get 2 over 1, which is 2. Here now we distribute the 2 through. 2k plus 2 plus k plus 3 equals 2. 3k plus 5 equals 2. 3k equals, oh, I'm going too fast, I'm sorry. Subtract 5 on both sides. Getting that 3k equals negative 3. Dividing by 3. And concluding that k is negative 1.